What's up, everyone? Now, sorry to jump scare you with the face reveal, but I kind of had to. It's been a hot second since my last video. I started a new job in November, and between that and moving, I haven't really had time to make videos. At least not until now. I figured that I would blow past what's left of the space and astrophysics iceberg and then move on to a completely new project, so I'd be more motivated to send out videos. So with that being said, we're going to cover the rest of this behemoth and hopefully things make sense by the end. Also, I'm proud to announce that we are no longer hosting the garbage Roblox gameplay. It's just going to be me talking about complicated space physics into the microphone. So at the very least, I hope you're into that instead of some very low res Roblox gameplay. I know the lighting might be kind of terrible, but I'll work on that, I promise. But on with the iceberg. As a quick reminder, each entry is ranked on a scale of 0 to 10, with 10 being things that are way more complicated, horrifying, or disturbing. I've kind of been forgetting to mention the whole scale thing up until now, but I hope you've been following along. Now let's go ahead and get into it, and of course, thank you for watching. Now, Tier 7 begins with the Pioneer anomaly. Now, Pioneer 10 and 11 were spacecraft designed to go into deep space. They were launched in 1972 and 1973, respectively, and their missions took them on flybys by Jupiter, and Pioneer 11 did a flyby of Saturn. Now, the anomaly refers to the unaccounted for change in speed of both aircraft once they reached a certain distance away from the sun. Basically, when scientists were monitoring the spacecraft, they noticed that their speeds were decreasing at a rate that was greater than usual. Now, since everything in the solar system is affected by the sun's gravity, it's kind of expected that they would slow down. But what was strange is that they were losing more than expected, of course. They were losing about 1 kilometer an hour over the course of a decade. It actually took the Pioneer team about 15 years to even begin to explore what was happening in the matter, until communication with both of the spacecraft stopped in 2003. Since then, the commonly accepted explanation for it is something called thermal recoil. Now, for some context, both Pioneers were powered by something called a radioactive thermal generator. It's basically a piece of radioactive material that with time sends off energy and powers the spacecraft. But if it provides heat in any particular direction, the laws of physics will make it so that the spacecraft accelerates in the opposite direction. It just so happens that accounting for this thermal recoil kind of solved the entire problem. So because it's been explained and it's not really any complicated science, I'm going to give it a 0 out of 10. Our next entry is Martian Waterfall. Now, Martian Waterfall refers to the Ecus Chasma on the surface of Mars. The Ecus Chasma is a small sort of canyon near the much larger Valles Marineris. Now, it's notable because imaging of the area has found evidence of very ancient waterfalls that once existed over this chasm. It's thought that lakes of liquid water once existed on the surface of Mars, and these waterfalls would be evidence of that. Now, the evidence for this is the presence of clay deposits and, of course, the overall shape of the canyon, the shape of which implies that some sort of liquid, in this case, most likely water, flowed over it. Now, this, of course, goes back to theories regarding Mars and whether or not it had water in the past. It seems like these waterfalls are some prime evidence and a good location to look for further evidence of water on Mars. The concept itself is not too complicated, but it is kind of cool, and it does imply that there may have been and may still be water on Mars, and for that, it gets a 2 out of 10. The next entry is space blindness. Now, space blindness is a condition that affects astronauts in which their vision starts to deteriorate because of how gravity works in space. The symptoms can range from general blurriness in the eyes to just flat-out blindness. Now, if you remember back to the puffy face entry, water in zero-gravity space rushes to the brain, and because there's fluid in the eyes and in the brain, this causes a lot of pressure to be put in the back of the eyes. What this can do is it can outright deform them, squishing them a bit, and this causes the aforementioned blindness. The condition seems to affect most astronauts in extended space missions, and because of the concerning health effect, it gets a 3 out of 10. STS-7 window damage refers to the 7th mission in the Space Shuttle program, which had the code STS-7. The mission was launched in June of 1983, and it was a mission that actually carried Sally Ride into space. Now, during the mission, it said that a very small piece of dried paint struck a window in the space shuttle, which damaged it severely. If you remember back to the micrometeorite entry, even small objects traveling hundreds of miles an hour are essentially bullets. They can cause massive damage, so much that a tiny piece of paint was no exception. And nowadays, just to be safe, the thickness of all manned spacecraft has been increased just in case. Now, again, just like that other entry, this gets a 3 out of 10 for literal space bullets. So Beepus on the moon refers to a small art project on a piece of ceramic taken aboard the Apollo 12 mission and pretty much left on the moon. On the ceramic little tablet are 6 pieces of art made by a number of artists, including, it says here, Robert Rauschenberg, who drew a single line, David Novros, who made a piece of simple abstract art, Forrest Myers, who made a computer-generated chain of lines, Claes Oldenburg, who drew his signature, which looks like some sort of Mickey Mouse, John Chamberlain, who made this cool pattern, and finally, Andy Warhol, who, as you might have guessed, drew a Beepus. Now, what's funny is that the art piece called the Moon Museum was never approved by NASA and was never supposed to be on board the mission at all. Like the corned beef sandwich, it had to be smuggled into the spacecraft. And what's even funnier is that the American sculptor who kind of sent the astronauts on the mission to leave it back on the moon never even told the press that he sent it until the astronauts were on their way back to the Earth. Now, supposedly the art piece was left on the leg of the lunar module, but there's really no way to tell if it's still there or if it's actually there in the first place. I'd like to imagine that in the future, we're going to send people to the moon and we're going to go back to that site. Someone's going to go check the leg of it and it's going to be there and they're just going to go, yep. So it's just a funny entry, and for that it gets a 0 out of 10. The Oumuamua spaceship conspiracy you might be familiar with because Wendigoon talked about it in his conspiracy theory Iceberg. Oumuamua is a rocky interstellar object that entered the solar system and approached the sun like a comet back in 2017. What's weird is that the object is shaped more like a very large splinter than a ball or a comet. And this leads to the conspiracy theory, which kind of asks the question of whether it's a space rock or a giant ship. While it's an interesting theory, if we look at how it's actually moving through space, we'll see that it's kind of tumbling and not, floating through space. It seems very hard to live in if indeed it is a spaceship, but maybe aliens have it figured out. Now I'm going to give it a 2 out of 10 because it's the first interstellar object to visit us. So, who knows what else might be out there. Dark energy is a kind of energy found in the universe, which is supposedly responsible for its accelerated expansion. The scary part about this is that we know almost nothing about it, despite it making up like 68% of the universe. But what we do know is that, according to Albert Einstein, more space can be sort of made. Now, don't ask me how this works, because I don't even think that he knew how it worked. But as more and more space is created, the universe begins to expand at an accelerated rate. This makes dark energy a sort of inherent property of space, and we can kind of think about it as the opposite of gravity. Now, because there is a lot of it in the universe, and it composes a great part of it, but we don't know a lot about it, I'm going to give it a 6 out of 10. The Great Attractor is a supposed region of space in our galactic cluster, which for some reason affects how a lot of galaxies are moving. Now, the anomaly was discovered in the 80s after astronomers noticed that for some reason, galaxies were not moving according to the expansion of the universe, but were instead being pulled by this attractor. It's estimated that for it to do this, the Great Attractor would have to be millions of times greater than the mass of our own galaxy. Now, the problem is that we really can't know where it is, and we can't look at it because of where it is with respect to the Milky Way. It just so happens that the attractor lies behind the brightest part of the Milky Way, placing it essentially behind the center of the galaxy. So imagine trying to look at, a tiny star behind the sun. Either way, it is either a very large object or a very powerful unknown force. And for that, it gets a 6 out of 10. String theory concerns a very theoretical concept that proposes that reality, at the smallest, most subatomic fundamental level, is made of an infinite amount of one-dimensional strings. The strings supposedly interact in such a way that they are responsible for the very laws of physics and matter as a whole. Now, as these strings vibrate, they enter different states. For simplicity, let's call them shapes. And these shapes sort of correspond to whatever the strings are representing. Now think of it as those AI images floating around that have this like background of pasta, but if you squint your eyes a little bit, you can see that it's like a picture. It's like that, except infinitely small strings curling up to make subatomic particles or, the electromagnetic force. Now, the general theory would help explain a lot of problems in quantum physics, like how particles interact with gravity. However, if we want to explain the reality of the universe in terms of strings, we really can't explain it using the 4 dimensions that we currently know. Now, if string theory is to describe the universe, it would imply that there are 6 other dimensions that exist, which we simply cannot observe and thus we can't prove it. It honestly is a pretty tough concept to grasp, but because we can't really prove it at all, it gets a 5 out of 10. Venusian dinosaurs merges 2 of my favorite concepts in science. Now, Venusian dinosaurs refers to the 1895 novel by Gustavus W. Pope. It's a science fiction novel and sequel to another one of Pope's books, Journey to Mars. Now, in it, the narrator travels to Venus and gives descriptions of its lush landscapes and whatnot, and among these, very large reptilian creatures. The narrator, of course, compares these creatures to dinosaurs back on Earth, and you can kind of see where Venetian dinosaurs comes from. Now, even though it was science fiction, a lot of people at the time had their ideas and theories as to what Venus looked like, or other planets as a whole, what they would have on their surface. And, this scene is a pretty standard created depiction of it. What we found much later, of course, is that Venus is literal hell and, nothing lives in it. But it's always cool to see what people could come up with back then. It would be funny, though, if you imagine that when we sent the first probe to Venus, instead of seeing like lakes of sulfur and acid rain, we just see the most confused triceratops. It's a fun entry, but it gets a 0 out of 10. Strange quarks are a type of subatomic particle related to the quarks that make up protons and neutrons. Typical quarks are up and down quarks, which make up the protons and neutrons, but there are larger quarks called strange quarks, which are found in other kinds of particles, which strangely seem to decay slower than ones that don't. The reason why is that strange quarks can only decay into something called an up quark. This in turn requires the weak nuclear force to interact with the strange quark and change its nature. But the weak force is super slow to do this. And we say that they last longer in terms of subatomic particle time thing because they still last incredibly short. In fact, it's about 10 to the negative 10 seconds compared to the expected lifetime of 10 to the negative 23 seconds, which makes them, last twice as long, but still we can't really detect it with our eyes. So cool concept, but it gets a 1 out of 10 for just being weird little guys. The many worlds interpretation is, in very simple terms, multiverse theory. Now, in this interpretation of reality, every possible outcome of any event happens in a parallel universe, but we only get to experience one, which is, of course, ours. Either way, the interpretation assumes that every single small event has an infinite amount of outcomes that branch out into other realities. If you're a Marvel fan and have seen the latest couple of movies and shows that have come out, first of all, I'm very sorry. You're kind of already familiar with the concept. Now, this kind of ties into things like decision theory, otherwise known as the butterfly effect, or the idea that a very small action will eventually snowball into a very large outcome. That being said, quite the existential headache, so I'll leave it as a 5 out of 10. Oh boy, so if you've been waiting for spicy government space conspiracy, as a joke, of course, the Zuma disappearance. Now, I don't want to harm myself in any way. This is all a Kerbal Space Program roleplay. The Zuma was a US government satellite launched in 2018, the exact contents of which were highly classified. It was launched by SpaceX, which we all love, and according to the COO of the company, the launch went smoothly and according to plan. However, supposedly, members of the government were notified that the craft had been lost. Because the mission is extremely classified, the government has not given any official statement about any of it. Even the manufacturer of the aircraft, Northrop Grumman, has pretty much refused to comment about the mission for the same reason. Some sources say that the craft fell back to Earth because it didn't separate from part of the rocket, and others believe that the government wants to keep its fate ambiguous because they really don't want us knowing what's in it. According to the Wall Street Journal, and I had to pull this from Wikipedia because I'm not paying for the news, the craft was sensitive to vibration and sudden shocks. Now, even though it's a spacecraft, if like a random telescope or satellite meant to beam information to a computer is damaged in space, it's not gonna, the government's gonna lose money, but it's not gonna. So yeah, sensitive to vibration and sudden shocks. Whatever that means, right? Surely it's not a weapon. Now, because this thing could be in space, it's kind of gathered some attention from amateur astronomers who have gone looking for it, but there haven't been really any leads. What I did find, though, is that shortly after the Zuma was found, someone tried looking for the Zuma and instead found an entirely different spacecraft that NASA had lost in 2005. So if anything, that's kind of cool. I guess if you want to find the Zuma, you can go ahead, but make sure there's no windows near you. For a totally not true government conspiracy joke, this is a 6 out of 10. That's going to tie up Tier 7, and Tier 8 begins with starquakes. Starquakes are events that occur on the surface of neutron stars that arise from unstable properties of the neutron star itself. Now, neutron stars are very dense remnants of supergiant stars, and as indicated by their names, are composed entirely by neutrons. A starquake happens when the surface is so stressed by the star's magnetic field that it suddenly readjusts its shape to be a perfect sphere. It's kind of analogous to the Earth readjusting itself when there's too much stress between two tectonic plates. So you get this sort of slip between the crust, and I guess in the star, which is several times bigger than the Earth, you kind of get this like squeezing. Imagine a giant earthquake, just hundreds of times bigger than the Earth. Apparently they can also happen because of the effect of gravity on the rest of the crust of the star, and when a starquake happens, a very massive amount of gamma radiation is just shot out of the star. Events like these are pretty short, they only last about a fraction of a second, but according to astrophysicists, an event like this would register around a 23 on the Richter scale. If you're not familiar with the Richter scale, it measures the intensity of earthquakes on Earth. It does this on a scale of 1 to 10. Each time you go up a number, that number is 10 times stronger than the number under it. So for example, a 7.0 earthquake would be roughly 10 times as strong as like a 6.0 earthquake, 100 times stronger than a 5.0, and so on. Now I ran a few numbers, and if my math is correct, which let's be real, it's probably not, the magnitude 23 earthquake of a neutron star would be 15 trillion times stronger than the largest recorded earthquake in history, which was the 9.5 Chile earthquake in 1960. And for that, it gets a 4 out of 10, because even though it's really far away from Earth, it's super violent, and a lot of radiation is just expelled from it. Now, the Lorentz factor is a value that describes the relative change in an object's dimensional measurement when it's moving. This is usually properties like length or time that appear to be measured differently from observers depending on who's looking at it. The value is denoted as gamma, and if the value is more than 1, then the measurement is perceived to be longer by the observer in question, and if it's less than 1, then the measurement is shorter for the observer. Now, if you remember back to the example I gave in the 4-dimensional space-time entry, it's something like that. When an object is moving, you can basically measure different things about it while you're moving at a different speed. A good example I saw online a bunch is the train car experiment. To picture it, you're standing in front of a train which is going at speeds close to the speed of light, and your friend is standing in the train car holding a flashlight in front of a mirror. The friend then turns the flashlight on and records the amount of time it took for the light to hit the mirror and bounce back to them. Now, with respect to the mirror, your friend isn't really moving, but in your perspective, it is, which means that for your friend, the light moved in a straight line to the mirror and back. But for you, from the moment that your friend turned the flashlight on, the light traveled diagonally as the train was moving, caught up with the mirror, and bounced back to your friend. And this makes this sort of V-line that, when measured, is longer than the distance recorded by your friend. If we know that the speed of light is constant for both of you, we can say that the distance covered by the light, as well as the time it took for the light to bounce back to your friend, was greater, for you at least. And in astronomy, this can be used to infer decay rates of certain particles that we really shouldn't be able to detect, but we're able to because we can measure their properties before they disappear. And for its role in relativity and some really weird physics, the Lorentz factor gets a 6 out of 10. The final parsec problem concerns a phenomenon that is seen when two supermassive black holes approach one another. Now, according to astronomical observations, two black holes that are approaching each other will for some reason not collide with each other, but instead begin orbiting each other at a distance of exactly 1 parsec, or about 3 light years. The reason why this happens is because the black holes don't get rid of enough energy so that they can merge into one another. Now, the reason behind this is because when black holes move through space, things that they interact with sort of take orbital energy away from it. But of course, as the two black holes come closer and closer, they pretty much clear anything around them, and thus they can't really lose any more of that energy so that they can come together. And this is to the point where if nothing interferes with their energies, they will never merge until the universe supposedly ends. But this is where the problem part comes in, because we have seen evidence of black holes merging. So the problem is, if it's impossible for them to merge in theory, then why do we see evidence of it? A lot of theories have been proposed as to how merges can occur, like somehow enough matter entered the system and disrupted the black holes enough to allow them to meet. But my personal favorite theory is the idea that a third supermassive black hole, somehow interacted with the orbits of the two massive black holes and disrupted their orbits so that all three of them merged, or the third supermassive black hole takes just enough energy away from the other two that the original two merge and the third just kind of goes away and is flung into space. The concept itself gets a 6 out of 10 because it's a bit less scary than a black hole, since it's just describing how two really big ones interact with each other. The Soyuz TMA-11 superstition has to do with the Soyuz TMA-11 mission, which was a mission to the ISS launched in October of 2007, which then returned to Earth in April of 2008 after the mission had ended. Now, the landing of the craft was a bit problematic. Basically, a component failed and caused all sorts of fun stuff to happen. Now, the entire crew made it back to Earth alive, but in an entirely different time and place where they were supposed to, about 300 miles away. The crew managing the mission on its return were Russian cosmonaut Yuri Malachenko, American astronaut Peggy Whitson, and South Korean astronaut Yi So-yeon. Now, the superstition part, it concerns comments made by the head of the Russian Space Agency, Anatoly Perminov, this guy. Perminov claims that there's a superstition saying it's bad luck to, and this is not my opinion, it says that it's bad luck to have the crew of the craft be mostly women, which is why there were supposed problems with the landing. Now, instead of leaving it there or even apologizing when he was criticized for the opinion, he then went on to state that it wasn't discrimination and that, quote unquote, when a majority is female, sometimes certain kinds of unsanctioned behavior or something else occurs. Superstition aside, most if not all major spaceflight disasters had a mostly male crew. And unsanctioned behavior? What? The man is onto something else. 1 out of 10 for literal misogyny. Moving on. Moons with rings is referring to Saturn's moon Rhea and a possible system of rings that may occur around the moon. Now, if true, this would be the only case of a moon with rings. That being said, evidence for the rings is a bit iffy. Now, in 2005, the spacecraft Cassini orbited Saturn and took a lot of data pertaining to it and its moons. One experiment that it did was it measured the pattern that arose when a moon blocked off a portion of Saturn's electron plasma. There's, a certain amount of radiation coming from Saturn. When a moon is between a spacecraft and Saturn, the portion that's blocked off by the moon is supposed to have a giant hole in it. What's weird was that for at least Rhea, in the radiation graph, there was the big gap where the moon was supposed to be, but then there were noticeable dips at either side of the moon. And what was curious is that these two dips were actually symmetrical. This was never the case for Saturn's other moons, or really any moon in the solar system for that matter. And adding to the evidence is a sort of line of fresh ice along the equator of Rhea. Since rings orbit at the equator, the idea is that fresh material along the equator would indicate that there's some sort of, debris falling along that line. Although the rings may possibly exist, there's really no concrete evidence, even when Cassini really, really looked for them. So the entry gets a 1 out of 10. It's cool to think about, a moon with rings. We haven't really seen that, but nope, not too concerning or complicated. The end of greatness. Now, on a cosmological scale, when we look at the distribution of stuff in the universe, we see highly random patterns and clusters of things like stars, galaxies, and larger compositions of these. But when we view the universe at scales of, 300 million light years, we kind of start to see that the distributions of things become much more homogeneous, much less, clustered in some spaces and, empty in others. But we kind of see this whole soup come together of the universe. You could also think about, microscopically, if you looked at it like a metal ball, at the surface of the metal ball through a microscope, you could kind of see very sharp imperfections in the surface of the ball. But as you zoom out, of course, the ball is still pretty smooth. The same thing applies to the universe, as when you zoom out of it, you start seeing less clusters of things, as we said before. And the greatness part refers to, of course, the great sort of big structures that you see formed when you look at the universe in smaller scales. There's really no conspiracy or advanced concept here, just a reminder that we're all extremely small, and for that, it gets a 5 out of 10. You might be a Boltzmann brain. Let me explain that. Now, a Boltzmann brain is a purely hypothetical, spontaneously created mind that arises from the chaos of the universe. Now, the idea is that the universe, by pure luck, just spawned a human brain with all of your senses, all of your memories, just at a given point, boom, you spawn into space. Now, who's to say that you are not that brain? Now, the concept comes from the idea that it's extremely unlikely for anything in the universe to be in the state that it's in with so much order instead of chaos. You know, stars, galaxies, matter, physics, and things like that. Everything we can study, and for us to be aware of it, much less. Rather, it's more likely for your brain to just spawn in the void of the universe with false memories of everything you know than it is for our universe to exist. Now, I'm again going to use Marvel as an example because I'm a massive nerd, but think of Ego the Living Planet from Guardians 2 and, you know, how he sort of like came into being, right? Now, the idea isn't widely accepted because there's really no point in assuming that you spawned 10 seconds ago in the middle of nowhere with all your memories. Despite this, the Boltzmann brain does encourage further understanding of chaos in the universe, like why has all of the energy and matter in the universe formed things that we can observe instead of just dissipating, or the very question of why are we even here? And for these type of questions, but a very futile way of kind of conducting this thought experiment, it gets a 4 out of 10. Now, dark flow is a theoretical concept that is kind of related to the Great Attractor entry. Now, for context, according to the cosmic background radiation that is distributed uniformly throughout space, galaxy clusters should be moving in a similar fashion, right? However, astronomers have found that they're slightly moving in a particular direction in space. Now, curiously, it's also in the direction of the Great Attractor. The flow part has to do with how the galaxy clusters appear to be flowing in that direction, and the dark part just refers to how, you know, we can't see it. That flow is unseen. The reason we can't detect what's causing it is because whatever it is, it's outside the observable universe. This could mean two things. One, it's in the region of space that contains light that hasn't reached us yet, or two, it's outside the actual universe. Now, whatever it is, astrophysics can't seem to agree on it. Some insist that it's evidence of a multiverse, and some even believe that there is no evidence of the flow at all. But like the Great Attractor, the entry gets a 6 out of 10 because it's a great unseen force that we can't explain. Merging of fundamental forces. There is a theory out there that says that at one point in the universe before the Big Bang, all fundamental forces of the universe could have been unified into one force. Now, the electromagnetic force, the weak and strong nuclear forces, and gravity would essentially have acted as one and the same. This, like a lot of things in the early universe, is purely hypothetical and would have lasted a fraction of a second, which each force splitting off into, you know, things that we know today. Now, the idea came after physicists noted that at high enough temperatures, the weak nuclear force and electromagnetism can be both combined and described as one force called the electroweak force. Now, these two are kind of related as both are responsible for electric charges, with the electromagnetic force being responsible for interactions between charged particles and the weak nuclear force being responsible for the charges of quarks and radioactive decay. Physicists then theorized that the strong nuclear force could then be incorporated at even higher temperatures. The problem lies with gravity because if you think about all three forces I mentioned, they all work on the atomic scale and smaller. So protons, neutrons, electrons, and quarks, that is all, you know, in the subatomic scale. Electrons interact with electrons, protons interact with neutrons, and things like that. However, gravity is so weak that in the atomic scale, it becomes negligible, like it doesn't matter. And because of that, it's kind of difficult to say what role it would play. Now, the unification of the three forces has not been confirmed. Obviously, it's a bit hard to visualize it, because how would you even study it? I mean, it would take a stupid amount of energy to even combine the weak and the electromagnetic force in the first place. Not to mention the remaining two. So I'll give it a 2 out of 10 for its theoretical applications for physics, but you know, it's not, it's nothing that we could ever study. CMB is quantum fluctuation. Throughout the Iceberg, I've been mentioning something called cosmic microwave background radiation, or CMB, CMBR. It's the same. In short, CMB is microwave radiation found throughout space, which was left over from the early expansion of the universe. Now, supposedly, early light energy in the universe was very low energy, shortwave, infrared light. Now, as the universe got bigger, this would have allowed the light to become even shorter wavelength, becoming microwaves. Now, quantum fluctuations describe small changes in the energy of any given point in space. Because the fluctuations existed right before the universe quickly expanded, it's then believe that the fluctuations expanded with it, sort of amplifying the chaos. It's believed that these quantum fluctuations then created these pockets of energy that then made larger structures possible. Now, if all this sounds very unintelligible, now I get it. This is astrophysics. I'm not a very good teacher, but from what I can gather, the entry is saying that quantum fluctuations in the early universe played a part in whatever created cosmic microwave background. At least that's what I learned from my sources. This is one of the hardest topics that I've had to research, so I'll leave a few useful links in the description in case my explanation inevitably is wrong or terrible. 4 out of 10 for such a difficult topic to grasp and its relation to the Big Bang. I would have ranked it higher because it is such a difficult topic, but there's really not much that can be said about it, so I'll leave it as a 4. Photons experience no time refers to, of course, how photons, like if you were a photon, how would you experience light? Now, basically, photons, for a bit of context, are particles of light, like little packets of light, right? Now, they, of course, travel at light speed, but this poses a bit of a problem with the equations of relativity. If you remember back to the Lorentz factor entry, this is referring to that equation. So if we're measuring the relative time that a photon experiences, which here is gamma, we see that the equation doesn't work. If you plug these values into the equation, the velocity v and c would be both the speed of light, right? C is typically the speed of light, but then the velocity v, since the photon would be traveling at the speed of light, they'd be the same. And since they're both the speed of light, this simplifies to 1 in the equation, and it makes the denominator of the expression 0. You can't divide by 0, so the amount of time photons experience is therefore undefined. If you were to plug in a value slightly under the speed of light, right, like 99.99% the speed of light, then gamma is defined, but it turns out to be extremely small. Plug in even smaller values and you get closer and closer to 0, but the moment that you plug in the actual speed of light, then you get 0 and the entire equation is undefined. Imagine you had a sentient photon, it would really not experience time, if that makes sense, which, to be honest, it doesn't, because the laws of relativity simply don't apply to it. Anyway, it completely breaks our understanding of physics and how relativity works, so I'm going to give it a 6 out of 10. And with that, we are done with tier 8. So we are now to the last 2, what are they, tiers of the iceberg. There you go. Tier 9 begins with quantum immortality. Fair warning, this has to do with self-harm and not being alive, so if you're sensitive to that, skip ahead to this timestamp, and if you are YouTube, screw you. Quantum immortality is a thought experiment that if, let's say, there is an infinite amount of universes, there are universes where you don't bite the dust because of the possibility of all events, right? There's a universe where you committed reach for the officer's gun. Then there's also a universe where you don't stop life by a bit. Then another universe where your stop life is delayed further, and so on. This would suggest that there's also eventually a universe where you live on forever. If you think about the many worlds entry, this would essentially be the one branching path where the sequence of events just results in you never stop lifing. Of course, we can't really test this theory because we'd only be able to observe one outcome at a time because we're 3-dimensional creatures, and then this would require like more than 3 dimensions for us to understand it, blah, blah, blah. It's more of a thought experiment than anything, and much like the Boltzmann brain, really shouldn't be taken too seriously, though it does pose some very interesting and thought-provoking questions. And for this, it gets a 4 out of 10. Yeah, let's get philosophical and totally not existential. Holographic universe. Listen, my monkey brain is kind of tired from recording, and the concept of a holographic universe might be what finally breaks me. The holographic universe concept is the idea that the universe is a sort of projection of 2-dimensional information. The main concept is that there is a 2-dimensional surface surrounding the universe, right, in which all the information, the Earth, physics, matter, atoms, all of that is written, sort of like code in a computer being passed through a projector. Just the 2D surface is a projector. Visualize that if you can. Except somehow this 2D shell around the universe makes a 3D projection, which is the entire universe. So yeah, somehow we're the 3D hologram made by the 2D information stored outside the universe. Now, the idea comes from the problem that black holes pose on the laws of physics themselves. Now, the issue is the laws of physics say that information like mass, energy, light, and things like that are not destructible but interchangeable. This is the whole E equals mc squared. You can't destroy energy, you can only convert it to mass. Now, this is true for everything except black holes, which seem to violate every law of physics imaginable. Information going into a black hole is essentially deleted from the universe, like gone. However, what physicists noted is that a copy of whatever information falls into a black hole is sort of preserved on the two-dimensional thing called the event horizon as a hologram. Now, think of when Mario collects a star in like Mario 64 or Mario Galaxy, right? When you go back to the same star, it's still star-shaped, you can collect it, but it's a hologram. But you could still see that that's where the star used to be. That same idea can be sort of applied to the universe, asking the question that if the universe and all the laws of physics, all of existence, is a kind of hologram that is being projected on a 2D surface, but we can't see that 2D surface. Let that sink in a little bit. I'm gonna rank it a 7 out of 10 because it's a very out there idea. It's unsupported, but it ties into the nature of the universe itself and black holes, and it's very complicated. So yeah, only one electron exists. This is what I believe. This is what I subscribe to. This is how I view the universe. So this is a funny one. So don't take it too seriously. The theory was proposed in a phone call between physicists John Wheeler and Richard Feynman in 1940. The one electron universe basically says that there is only one single electron in the universe. Think about it. They all look the same. They all act the same. And have you ever seen two electrons in the same room? What the theory says is that every electron in every atom that has ever existed in all the matter in the universe is the exact same one, and it achieves this by time traveling. It also says that the electron can travel backwards in time, and when it does this, it creates the antimatter equivalent of an electron, so a positron. The only problem is, if that's the case, then there has to be approximately an equal amount of positrons in the universe than electrons, which is simply not true. They are not very common in nature. Well, there's a bit more to the theory, like how it could possibly explain the quantum entanglement theory. And this is just the idea that any two subatomic particles, no matter where they are in the universe, like doesn't matter the distance, they are in some way connected. Like they know they are there, if that sort of makes sense. But you know, there's no evidence that the theory is at all how reality works. It's just, the concept is bizarre in general, and Wheeler even later wrote that he didn't believe in it anyway, so it's just, don't take it seriously. Time traveling electron. My brain hurts enough as it is. 1 out of 10. Okay, so this next entry, I do not like this entry at all. Everything is a spime. To start off with, a spime is a term coined by Bruce Sterling, who is a science fiction writer. Its exact definition is a little complicated, but from what I can understand, it's a proposed futuristic sort of object that seizes the need to be physical and whose information can instead be accessed anywhere. The word is a portmanteau of the word space and time, and a way to visualize it is to pretend that you're a computer and any given file in the computer is a spime. You're given access at any point to pull up a file or a program or things like that. Like that program or a file, that would be to you a spime. Now you'd be able to access and use every file within your reach, as well as know its exact location. Now in physical life terms, this could be like a mug, your glasses, a watch, you know, anything, except they're not really physical and are instead like data. They're just an idea that can be grabbed like out of thin air. Like you could know where it is, and you could, you know, represent it as data. Now the idea came up as a sort of way to end the need for physical objects, a sort of way to reduce waste and account for things, like account for all things. So if everything was a spime, they're just information out in the universe, and you could grab them from I guess hammer space if you wanted. And because of this, spimes would be everyday objects, but they would replace the identity of the object, and instead of becoming the idea of it, they would only ever be the physical object when you needed it. A good way to think about it is like think about how past technology is constantly being replaced by more advanced things that do the same function, that have the same function, have the same need. So think about how animal skins were replaced by paper scrolls. Scrolls were replaced by books. Books eventually replaced by PDFs or, digital technology, things like that. Eventually you get to the point where everything around us is just a virtual entity and we can somehow turn it back to data. Thus we get a spime, I think. It's complicated. The entry, however, is suggesting that perhaps everything is already a spime. Think about the holographic universe entry and how everything in it might be stored as information in a location outside of our universe. Now, if this is true, then all objects in the universe, including you and I, are basically spimes because the universe has stored our information and projected it as physical. For whatever is outside our universe storing this information, the universe and everything in it would be a spime because whatever is stored it is able to make the laws of physics work and thermodynamics, gravity, everything really, all in perfect sync with one another, therefore knowing where to put all the code, all the information. I have a headache. Nothing is real. Information about spimes is scarce on the internet. I can only find a couple of references to it, and I am not reading what's his face, Starling's entire book to understand them. I deeply apologize for this bizarre topic in general. I wish I could tell you more about it, but that's really it. Again, I apologize if nothing made sense. But it's a wild ride. This is what I came for. This is why I made this Iceberg in the first place. 9 out of 10 because it's very, very difficult to grasp. Now, Edgar Mitchell was an American Navy pilot, engineer, and astronaut who flew aboard the Apollo 14 mission and was one of the 12 people in history to land on the moon. The entry, of course, refers to his strong belief that UFOs and aliens not only existed but had visited Earth multiple times, and that the United States had alien bodies and alien tech. He believed everything from the Roswell incident being true, or at least involving aliens, to aliens being a sort of peacekeeping entity between the US and Russia during the Cold War, and also that world governments are all hiding the truth and that aliens have contacted us many times. NASA, of course, has denied this, but Mitchell also claimed that other governments and military officials confirmed to him that aliens have visited Earth multiple times. There's no denying that this guy was well respected and very bright in his field, but it seems like his views on aliens came from a place of spirituality in his life rather than concrete evidence. He was a NASA astronaut. He could know like so much stuff that like a regular citizen would know, and for that, sure, I guess this could be true, but for everyone else to be keeping quiet, I mean, there was that one guy last year who okay, there's no sniper outside my window. Anyway, back to Mitchell. Mitchell liked to share that he had a sort of spiritual moment while he was in space. He describes how he realized that the universe had made him and was, in a way, like communicating with him. And his understanding of that fact was his enlightenment. And he later went on to write books on this experience, but he also became in a lot of mystic and psychic research, which makes me not want to believe him. Now, this isn't at all to say that he should be outright discredited just because he believed in less scientific matters. I don't think it means that he wasn't a brilliant man. It makes me want to take his word on UFOs and aliens with a grain of salt, but besides that, I give this entry a 1 out of 10 because it's just a beliefs of one person, but on the off chance that they're true, could greatly affect how we see our role in the universe. False vacuum. So okay, before I explain the entry, we need to go over something called energy states. The laws of physics and thermodynamics tell us that objects with high energy will inherently want to be in positions where they have the least amount of potential energy, because that's really just where they're the most stable. So something like a can of gas will light on fire and burn out. An object in an elevated surface will fall to a lower elevation, things like that. It even applies to subatomic particles like electrons, where if you remove a number of electrons from an atom, then the electrons within that electron cloud will rearrange to make the atom more stable. With that in mind, the most stable state of an object, it's called its vacuum state. Now, bear with me, we also have to talk about the Higgs boson and the Higgs field. Now, if I had to go through this, so do you. Now, the Higgs field is a fundamental field that gives things mass, and it's created by the Higgs boson, which is another fundamental particle. It's not the most straightforward thing to grasp, but this thing is what makes all the matter of the universe possible. The Higgs boson just kind of makes objects exist. What the entry is saying is that perhaps the Higgs field found in all matter is not at its vacuum state, at least not entirely. It's the idea that maybe the Higgs field, or all Higgs fields in the entire universe, are currently pretty stable, but could be at an even more stable energy level. You put all of this together and you get a universe-ending scenario. If any Higgs field in the universe decided to drop down to a more stable energy level, it would release an unfathomable amount of energy that it would destroy Higgs fields around it. So let's say like a single, what has mass? A proton. A proton within this bottle cap just entered an even lower energy level. That would destroy the atom next to it. It would just be like a bomb, a giant bomb. Now, obviously, this would cause a very destructive chain reaction until the entire universe is pretty much obliterated in the blink of an eye. You wouldn't even notice. It would be light speed how instant this would be. As this happens, the laws of physics shut down completely. Gravity, if it still exists, no longer functions the same way, and subatomic particles can't form because there's no atoms and therefore no matter. Again, it's not proven if this could happen, but nevertheless, it is worthy of the first and only 10 out of 10 in this iceberg. The speed at which this would happen, it wouldn't even allow us to register what's going on. We'd exist 1 second and the next, nothing would. And what's scarier is that the universe would be left an incomprehensible shell of what it once was, with matter and physics just gone. Yeah, that's it for vacuum decay. Moving on. The solar system is a zoo. This is another fun entry. It's my least favorite fun entry because what's even the point? It's kind of like simulation theory, right? It's more or less a thought experiment to try and explain why we see no evidence of aliens at all, and also has to do with like the Fermi paradox that we talked about earlier in the iceberg. Now, the theory says that the solar system is either A, fabricated by another species, like alien species, just to see what happens, or B, intelligent life in the universe specifically avoids our solar system in every way they can, just because they don't want to influence our development. Now, what this would mean, at least for the second one, is that aliens can somehow, like every signal that an alien spacecraft or an alien planet would send out, they would sort of curve around our solar system and prevent them from, ever being detected. And essentially, the entire theory treats the universe as an experiment, like a zoo. Like aliens just view us as animals that they don't want to touch because they don't want to disturb us or something like that. Now, as I said in the simulation entry, we'd have no way of knowing this because, again, they would make themselves uncontactable and imperceptible. So why even bother making it? I mean, at least they made our lives somewhat comfortable. I'm going to give it a 4 out of 10 because it's way less believable than the simulation theory, but still makes you think about why we haven't found evidence of aliens yet. And to finish tier 9, we have higher dimensions are folded up at the Planck length. Now, remember back when I talked about string theory and said that if it were true, there must be more dimensions that are so small that we can't even detect? Well, this entry describes why we can't study them. The reason being they might be in one of the smallest measurable scales, the Planck scale. The Planck scale is defined by Planck length, which is 1.6 times 10 to the negative 35th meters. This is beyond subatomic, smaller than electrons, smaller than quarks, and it's even smaller than the theoretical range of the weak atomic force. The reason why nothing can get smaller is because past that, gravity just doesn't work. And in fact, gravity even barely works in Planck length at all. But going back to higher dimensions, right? We can sort of visualize the concept of them like this. If you have a one-dimensional line on your computer, you zoom out. Eventually, the line is going to become just a point, like a single pixel. You won't even know it's a line until you zoom into it. Let's say you have a two-dimensional rectangle and did the same thing. You have a rectangle and then you zoom out enough where it just became a line and then it became a point. Now, the same could work with higher dimensions, things that are so incomprehensible in their spatial composition that you have no idea what you were looking at because your 3D brain simply can't. An easier way to visualize it is to just imagine a very, very small object. So let's say you zoomed in on a very complex object to try and make sense of it. Eventually, you're going to come to the point where you can't zoom in anymore because things past this just won't make sense. The universe won't let you. And that would be those dimensions. Overall, the concept gets a 2 out of 10 because the dimensions are purely theoretical. So it's not too concerning, but it's still a pretty tough concept to understand. And with that, we have reached tier 10, the final tier on the iceberg. Now, I want to thank each and every one of you for watching this video and for watching the last videos. This is my first YouTube series. I know I haven't been consistent, but thank you for watching regardless. I'm still getting used to, this whole performing, reading while looking at the camera kind of thing. My voice hurts, but I will do my best to practice and become better. Hopefully we have a bit of an audience by the time that the end of the year hits. So I hope you've enjoyed this journey into deep and complicated space as much as I have. So let's begin with tier 10, and tier 10 begins with the universe might be a fundamental particle. So this theory explores the mind-blowing possibility that our universe functions as a fundamental particle for another larger universe. What this would mean is that there's a universe beyond our universe that is a bigger, much more complex universe. All of its matter is made of particles, which themselves are smaller universes. This would sort of validate a lot of the previous theories, like the mini-universe hypothesis, since there would be countless particles in that universe that function themselves as universes, and therefore those alternate worlds. However, that brings a lot of questions as to the truths about our universe. If our universe is expanding, then what does that mean for the larger universe? And if there are other universes acting as its fundamental particles, then that makes all fundamental particles slightly different from one another. And that doesn't sound like it would work unless they're all identical. A fun theory of mine that I came up with for this entry is that perhaps every fundamental particle in that universe has the potential to become its own dimension. And many of them actually do. When certain particles decay in our universe, they release energy. Not a lot in the grand scheme of things, but they do. What if, now hear me out, our universe used to be a fundamental particle in a larger universe, but through the process of decay, released so much energy in that universe that it created our universe in a smaller dimension. As always with this kind of theory, there's nothing to prove it. I'm overall going to give it a 4 out of 10 because it's a bit existential, but it's not that bad. The axis of evil is a phrase first used by George Bush to describe countries he thought were a threat. After 9/11, I'm kidding. The axis of evil is a term describing how the orientation of the solar plane and certain properties of cosmic microwave background radiation line up in a questionable way. Now, the solar plane just refers to how everything lines up around the sun. You have the sun, and then you have things in a very relatively flat area orbiting the sun. So it makes like this sort of plane and then the sun in the middle. What the observation suggests is that the solar plane suspiciously coincides with the sort of temperature of the CMB. As we established in previous entries, the CMB is relatively uniform around the universe, but if you divide the universe in certain ways, then you get an odd kind of pattern. Now, we call the ways to divide things in reference to poles. So a dipole divides an object into 2 halves, a quadrupole into 4, an octupole into 8, and so on. It turns out that if we do this with the universe, we can see that the quadrupole and octupole ways of slicing the universe make this kind of division with regards to the cosmic microwave background. Coincidentally, the solar plane lies exactly at this angle of division, so it kind of splits it. And it really shouldn't. There's something called the Copernican principle, which is the idea that our place in the universe is not really special and we're not at the center of it. This, of course, comes from Nicolaus Copernicus, who first adopted the idea that Earth and all the planets revolved around the sun, not the other way around. I mean, I'm pretty sure that he wasn't the first one. He was like one of the first ones to get it out there, With that in mind, the idea that our sun is perfectly oriented in such a way that it borders the cool and warm half of the universe is a little difficult to accept. It might just be a total coincidence, but astronomers are still trying to reason what this means in regards to our role in the universe. I'm going to give it a 5 out of 10 because it's too big of a coincidence, and I'm not saying the solar system is the center of the universe, but maybe we give our existence less credit than it deserves. Reality is just information. Now, this describes the idea that everything we can see, measure, and perceive is really just information. If you think about it, this entry is true depending how deep and theoretical you get. You could go through the holographic universe approach and say our reality is a 3D projection of two-dimensional code, as we went over earlier. But since we already had an entry like that, I want to take a different route. Imagine that you're looking at an object. You can describe the side of it as the light source hitting it is bouncing off of the electron surface, which is made possible by whatever bond is holding the object together. In this case, it's a bottle cap made by plastic. I assume it's a covalent bond. The bonds of the object are possible because the atoms of the object are having chemistry with each other. This chemistry, of course, is a property of the protons, neutrons, and electrons of the atoms. Electrons are small electrically charged particles described by a quantum spin number in their orbital. Each proton and neutron is described by the constituent quarks and their charge. Light hitting the object is made of packets of light and a known wavelength, and a known speed reflected into your eye, where you can perceive it using the electrical signals in your brains, which also performs chemistry. At this point, we've arrived at a point where we can describe an object based on the information it carries. A sound wave works similarly. Sound itself is just a wave, which is described by wavelength and the speed of sound in its environment. This is the case with everything in the universe, so in reality, everything can be broken down into bits of information that all come together into objects we can describe. It's certainly philosophical up to a point, but you can't deny that it's true if you think about it. We're just fortunate to have brains that transform this information into something that makes sense. Overall, I give the entry a 3 out of 10 because even though it makes you break down everything into such basic ideas, it shouldn't bother you too much if you don't keep thinking about it. Living stellar objects is an idea that there could be non-organic living objects on the surface of some stars. Biology made of the elements we're used to just isn't possible in star temperatures, right? But a way life can happen here involves much colder stars than our sun to have heavy metals, which don't really melt in the heat of the star. An example of this is a red dwarf, some of which aren't really hot enough to melt certain metals. What this could do is allow for a different kind of life based on these different metals, but it really wouldn't be what you expect. As stated before, chemistry doesn't really happen in the heat of the star, so these potential life forms would subsist on thermal radiation, energy from the star, even radiation itself. There's also another more abstract idea saying that stars and large objects of the sort have consciousness and are thus living beings. Now, there's not a lot about this one online, but I thought I'd mention it anyway just because no theory is too ridiculous at this point. I mean, if you're going to consider things like the universe as a hologram or a fundamental particle of a larger universe, you might as well say the sun is sentient, because why not? 1 out of 10. Another universe seen in the cosmic microwave background. Do you remember how in the Axis of Evil entry I mentioned that one side of the universe is a bit colder than the other? This is because of something called the CMB radiation concept. If you recall, the CMB is relatively even throughout the universe, but because of fluctuations, some regions have lower or higher energy. Now, this specific cold spot, I'm going to put an image on the screen, is one of those regions, and it really should not exist. What the entry says is that this cold spot is supposedly evidence of a collision with our universe and another universe, the impact of which sort of left this imprint in the CMB. If you remember what the CMB is, this would mean that early in the universe's formation, another universe would have supposedly, collided with ours and disrupted that part of the CMB. That disruption would then perpetuate throughout the universe and let us see the spot. Think of how when you blow up a balloon, the rubber stretches pretty uniformly, right? Now, if you took a Sharpie and kind of drew on the balloon right as you started inflating it, the spot's going to get a bit bigger. It's not going to be like as dark, but you could see where you put the spot. Pretend that the spot was made by a universe covered in ink, and you start to see the picture. Well, it may be cool to leave it at that. Astronomers pretty much might have already explained it. In 2015, astronomers discovered the presence of a supervoid in the direction of the cold spot. If you heard about the Boötes void, this one is even bigger. A region of space is called a void if it contains an unusually low amount of galaxies, with a supervoid containing an unusually low amount of galaxy superclusters, which are, clusters of galaxies that are even bigger than normal. So even less stuff floating around in a stupidly large region of space. As it turns out, accounting for this supervoid might actually explain why there's a cold spot there at all. Of course, this means that we have to do a little bit more research, and trying to research something that is millions of light years away from us isn't really easy. I mean, we have like that new James Webb Space Telescope to help, but still, like we can never know for sure, in my opinion. Despite that, I'm going to give the entry an 8 out of 10 because the thought of an unfathomably large region of space being mostly devoid of galaxies gives me absolute nightmares. Backwards time travel is possible inside a black hole. So this entry kind of gave me a headache to figure out, but here we go. Assuming one could even survive going into a black hole, the idea of backwards time travel can happen in two very hypothetical scenarios. The first scenario assumes we have a structure with two black holes at either endpoint. Now, this is called a wormhole. If you went into one end of it, would be transported instantly into the other end of it, no matter how far the two black holes would be. I found this explanation online that I'll give to you in a bit, but I'll give you my full confession. I have no idea how this works, and I'm tired of pretending I do. Here's what I found. According to astrophysicist Ethan Siegel, you can travel backwards in time with the following conditions. You have a wormhole with 2 openings, as we've stated. One of them is near the Earth, and the other one is traveling into space at the speed of light. For the purposes of the video, this bottle cap is the stationary black hole near the Earth. This is going to be the traveling black hole. So let's say you're near the traveling black hole and entered it after a given amount of time, and when you come out the other end, you would have gone back in time. And depending on how long the wormhole traveled for, the earliest you could go back in time would be to the point where the wormhole was created. Our second scenario is much harder to understand. I understand it even less than the first one, so I'm not even going to bother trying to explain it in full detail. According to a video that I'll link in the description, you can travel around this black hole and end up in the same location that you started to go around the black hole, but in the past, before you actually began. This has to do with things called light cones and other things called world lines, which I am in no way going to try to explain because I'm at my limit and I have one last entry to try to explain. So if you want to know how this works, you are more than welcome to watch the video in the description. Anyway, time travel, 6 out of 10. We can never do this, by the way, in case you're wondering. But everything's purely theoretical. Just, it's very complicated, so it gets a 6. And with this last entry, we have the end of the Space and Astrophysics Iceberg. I want to thank you all for making it this far. I appreciate you all. Let's talk about the last entry. Now, the final theory on the iceberg says that all energy, and therefore all reality, in the universe is the result of one wave interacting with itself. The physics definition of a wave describes it as a disturbance that travels through a medium in space, carrying any variation of energy from one point to another. So in physics, everything is pretty much a wave if you look at it a certain way. If you zoom in enough, you can calculate the significant wavelength of particles like electrons and photons. And from light all the way to planets and stars, you can calculate what's called the Broglie wavelength of an object, at which measuring it just becomes essentially useless. So really it's only applicable to small particles. But because everything in the universe is made of particles, we can then think of everything in the universe consisting of many waves working together. Now, the theory states that all of these waves are actually a single wave, a concept similar to the one electron universe entry we had a while ago. And this wave, like that electron, would be infinitely traveling back and forth through time and space. Okay, as it does that, it interacts with its past and future selves, making atoms, energy, heat, and effectively making up reality. So if you take that concept that the electron, that there's like one electron that represents the entire history of the universe, I guess, change that to a wave of energy and have that wave time travel, and then that wave colliding and interacting with itself just kind of makes this mesh that we call reality. Okay, now stay with me. This would mean that not only can this stupid wave time travel, but it can be in the same location at the same point in time multiple times as much as it wants to be able to interact with itself and form the complex structures we see, like matter, forces, and every possible thing in the universe. Now, research for this topic led me to another concept called the universal wave function. This unknown function could again be used to describe every single possible thing in the universe. And according to an article associated with MIT, which I'll link in the description, the function would be able to describe the following: the position of every particle in the universe at a moment in time, all possible positions of those particles at that time, and all the possible positions of those particles at any time. And if you remember back to the many worlds theory, this concept would sort of validate that, because the function would then by definition describe other possible universes. It does that especially when it describes every possible position of particles at any time. And those possible positions would theoretically be alternate universes, because whatever the function is describing could have been there. Truly a difficult concept to visualize, but think of it like a screen showing you an object on a table. A number of things are able to happen to the object. Someone can pick it up, it could be knocked off the table, any number of things. This final entry of the iceberg is honestly a 4 out of 10, mostly because it's hard to understand and it's a bit bothersome, because you're essentially saying that the many worlds hypothesis could be true, and if true, could be plugged into a function that could somehow describe everything in all universes at any point in time. The idea of a universal wave function is really what gets to me. If we had this function and we were able to predict all the things that it entails, we would quite possibly be able to understand the universe as a whole. And the very thought of that is a bit concerning, and I don't like it. What more could humanity achieve if it knows where everything is at once and where it could be at any time? Part of me hopes we never figure out that function, because at least for me, knowing everything about the universe sounds more frightening than knowing nothing at all. And that will conclude the space and astrophysics iceberg. It's been quite the journey, especially with that giant hiatus. Life just kind of got in the way. I love when the historical and astronomical entries began to turn into quantum physics and whatnot. You know, it's only fitting that the last couple entries of the iceberg were purely hypothetical thought experiments. Like, we as humans desperately look for patterns in nature, and sometimes we try to make sense of them in any way we can. The universe is no exception, and it's arguably more mysterious than anything we've studied. Like, the wave universe theory might make sense for someone, but then to someone else, like, they may like the many worlds theory better. But no matter what you believe, whether it's a universe creating God or you just go the science route with the Big Bang, you gotta admit that however the universe came to be, that same process made you. And you're here to marvel at the beauty and mystery of the same universe that gave you your consciousness. I want to thank each of you one last time. One last thanks to the creator of the iceberg, Mellow Affinity on Reddit, and the physicists over at Fermilab on the Fermilab YouTube channel. I could not have done it without you. Some of these topics they were impossible to understand with the simple brain that I have. Thank you for being here. Thank you for watching, and I will see you soon.